Today we're going to switch this platform so that we can instantiate it programmatically. To do that, we're going to remake some of the objects, but we sort of know what we want it to look like, so it won't take as long. I'm going to start by making a new cylinder. At 1, build it. Maybe at 0.5 to make it 1 in total. The reason we're doing this is to keep everything consistent within the system so that our computations at the end are a little easier. Now we have a cylinder with 1 as its size, 1 being a meter in Unity. We're going over to the pipe. We'll set its radius to 0.5 to get diameter of 1. Get rid of the preview, get rid of that. Now we've got two things. I'm going to hide our current platform. So we need to center them because ProBuilder builds kind of on the edge. So we're going to go and center their pivots. See if we can get them in the middle. Yep, I'm going to exit out of ProBuilder. So the pipe is above by a little bit. So we want to continue to move it. And it looks like 0.25 puts us at the right location so that it's sitting just on top of the cylinder. If we go a little higher, we can, yeah, 0.275. We have the cylinder. I'm going to make a new empty object. We're going to call this one platform. Eventually we'll be deleting the other platform and replacing it. So now we have the make sure everything's zeroed when you're parenting, otherwise you have to go through and do it again. All right. From our original platform, we've got some materials we can use. So I'm going to take the material, that was pattern 6, and put that back on our pipe, and then our cylinder is using metal pattern 15, so we can drop that down. Next, we need to do the collisions as we did last time. Switch over to physics debug. So the cylinder, the platform that we have here has some colliders on it. We need to add a few more for the walls and the ceiling. So we're going to see how we did that over here. Looks like a mesh collider on a ProBuilder object without anything on it. So we're probably going to duplicate these, get rid of the mesh renderers, and then stretch them. There we go. So it's 1 as diameter. We could do 2 and then raise it. 1 puts us on top. 0 starts us at there. 0.5 puts this collider sort of everywhere the first one is. And just to make it less likely to collide into itself, I'm gonna shrink it down a pinch, and now we have the ceiling to work with. Ceiling we just want to slide up so that it's on top of the walls. It's probably going to be 2. Now 1. Yep, that works out well. And now we have the same platform we had earlier, except now we can throw it in our resources folder as a prefab. And I'm going to get rid of these. So now we have just this. We'll call it setup form. Should throw an error if there's no platform. Yeah. We can fix that in a minute. So now we have setup. In setup, we want a public float that's going to be the platform diameter, radius. Let's set it to 6. 6 is where our platform was previously. So when we wake up, we want to instantiate that. Let's switch these to private. And then we're going to load it like we loaded the targets. We're going to load the platform from resources. We're going to add a private void. And call it set platform. We want to set our platform up. We can just set it to itself. We'll say transform. So this is going to spawn it and then parent it in the transform that it's already on. See what that does. When we go back to Unity, I'm going to switch the control script off until we have a chance to respawn the platform. This is coming from setup 3137. Oh. Use this. Let's see what happens. That worked. We have our small platform loaded. Now we can set the scale. So the height isn't going to change, but we're going to set the scale. And it's going to be the radius that we're setting. So that worked out. We're not finding the target folder because it no longer exists. So we can get rid of that, the code to parent it. And see what happens. Now we have the platform and the target spawn. So we can set the distance, but the width is inferred based on the number of spheres. We should set the scaling factor of the width as a public variable, and then we can manipulate both. Going back to our code, so we have this 0.75. We're going to set a public float. We can call it W. And we'll make it a range 0.1 F to 1. We'll see how that works. Then we'll set that there. We'll move this up top. I'm also going to change the platform radius to D so that we have the Fitts law naming conventions. And now that we're starting to develop these up, I'm going to add some summaries. So W is the scaling factor for the targets. And we're going to put D as the diameter. Now we have this distance from center. We need to adjust so that the platform is not based on D. So I'm going to go ahead and just delete distance. We don't need it. I'm going to add a summary for targets. Now we have D, that's the diameter, so we can use it in the scale of the platform, but this would bring the platform to the ring. So our targets would be half in and half out. So we're going to do float, call it padding, and it's going to be the scale of the targets we have. And we want to maybe multiply it by 3. This will give us one full target on each side so that the controller or the sphere in this experiment can travel outside of and then enter back in. Now for the distance from center, we can just change that to half of D, which would be the radius. And if we play it, unexpectedly huge. 77. Plus padding. There we go. Yep, that's what we're looking for. So now we have one full target on the edge of each target. We can test that by grabbing one over about a little bit less. Instead of multiplying it by 4, I'm going to add it to itself. And that worked out. Now we have about just a little under a target extra. I'm going to go over to our setup, reduce the diameter to 6. See what we got. Next, we want to have this player parent itself in setup, and we also want to add the controls back. So we have this player script, going over to it, just instantiates, say, we'll attach it to whatever the object is that the script's on. We can just move that script over to setup. Let's see if that works. Did, except it's too tall. So I'm going to go back to our resources folder, the platform. This is, let's make it 4. Bring it up by 1. And the ceiling will go up by 2. See if that gives us enough space for the player to spawn in the right spot. Yep, perfect. We look at it, our physics debug, we've got it pretty much working out. Now the controls, which were attached to here. I'm going to move them over to setup, get rid of manager. With the controls in the setup, we can just turn them back on, attach that, and now we have, it should be a functional game again. So the key differences are now we can use some of these variables, like the number of targets, the width, and the distance, to change parts of our bit wall study. The platform and all of the targets are all in the same local space, and so is the player. So now we can track the local space relative to each other instead of the global space. And with this tilting, the optimal path for the ball will remain constant on the surface of this area, but it will be moving around in space, so we'll have to compress it back to 2 dimensions before we do our analysis.